All right, athletes, here's 3.1 quadratic functions. So some vocabulary on quadratics. We have two different forms of quadratic. One is our general form, where it's ax squared plus bx plus c. The second type is our vertex form, where you can identify your vertex to be h and k, where hk is our vertex. Okay, the graph of a quadratic function is always a parabola. All right, so some other things. So our vertex is the highest or lowest point on the graph of a parabola. How do you know if a parabola opens up or down? So if it opens up, you know the vertex is going to be the lowest point, and you're going to have a minimum value. If your vertex opens down, you're going to have a highest point, and your vertex is at highest points, and you'll have a maximum. Okay, you always know if the parabola opens up or down from your a value. If your a value is greater than 1, meaning it's positive, or I guess it's just greater than 0, it just has to be any positive value, it's going to open up. If a is negative, it's going to open down. Okay. So some properties of some quadratic function. Your vertex from your standard form, and you have ax squared plus bx plus c. You can always find your vertex by doing negative b over 2a is going to be the x value of that vertex. And then to find your y value, you just got to plug it into your function, and then you get the y value of your vertex, so then you can have your x and y. The line of symmetry always goes through your vertex, and it always goes through the x because it's a vertical line. So your line of symmetry is always negative b over 2a. So that will help in some problem solving and finding our vertex. So first example here, without graphing, locate the vertex and the axis of symmetry of the parabola defined by f of x here. So first thing I'm going to do is identify my a, b, and c. So my a is negative 2, my b is 8, and my c is negative 3. So if I want to do negative b over 2a to find my x value, I'm going to get negative 8 over 2 times negative 2. This is going to be negative 8 over negative 4, which is equal to 2. So that is my x value for my vertex. To find my y, I got to do f at 2 and evaluate that function. So I get negative 2 times 2 squared plus 8 times 2 minus 3. So here I have 4 times negative 2, so that's going to be negative 8 plus 16 minus 3. So I have 8 minus 3 is going to be 5, so 2, 5. Because my x value of my vertex is that, I know that my line of symmetry is going to be x equals 2. All right, let's look at another example here. So for this one, we're going to do a couple steps, eventually graphing this function by hand. So x squared minus 6x plus 5. Does the graph open up or down? Is a vertex a maximum or minimum? Well, my a value, there's a 1 here, so a is greater than 0. So therefore it opens up, just like this. If it opens up, we have a minimum. Okay, to find my y-intercepts, I know when that's when x is equal to 0. So I let x equal to 0, and I get 5, my c value. So that's my y-intercept. To find my x-intercepts, I want to let y equal 0, or my f of x, so I get 0 is equal to x squared minus 6x plus 5. So remember, here we are solving a quadratic. So to solve a quadratic, we have more or less 3 strategies. Remember, our first one is trying to factor, and then zero product property. Our second strategy is complete the square. Or our third strategy is our quadratic equation. Okay, so I always like to try and see if things factor first. It's typically the quickest. So things that multiply to be 5 and add to -6. So I get -5, -1. So without an a value, I can just go ahead and say that this is x minus 5, x minus 1. So x is equal to 5 and 1. So if they're x-intercepts, let's go ahead and put those values as a point. So it's when x is 5, my y is 0, and when my x is 1, my y is 0 as well. So I'm still working with the same equation here. And so to find my vertex, I'm going to use my negative b over 2a. Well, for my function, my a was equal to 1, my b was equal to -6, and my c was equal to 5. So I plug that in, I get -6 over 2 times 1. This is going to be 6 over 2, which is equal to 3. So to get my vertex now, I have to plug that into my function. I have my x value, so f at 3 is equal to 3 squared minus 6 times 3 plus 5. So I get 3 squared is 9 minus 18 plus 5 is going to be -9 plus 5 is -4. So my vertex is 3, -4. Okay. So what I want to do is I want to now use all those points and use that to help me graph here. So from the previous slide, I know that my y-intercept is at 5. I have an x-intercept at 5, 0. And I also have an x-intercept at 1, 0. And then I know my vertex is at 3, -5. So using those 3 points, I can also use some symmetry, and I can say, all right, this point over here has to be over there, because if I have this line of symmetry at x equals 3, symmetric there. And then to finish my graph, I can just go ahead and connect my dots and draw my parabola there. And now if I want to rewrite the equation in vertex form, I just need my h and k values. Well, that h and k value is my vertex, which is 3, -4. And I need my a value. My a value is 1. So now I can rewrite f of x in vertex form, doing 1 times x minus 3 squared plus a -4. And that is the same equation in vertex form. Okay, let's look at another example here. Example 3, determine the quadratic functions whose vertex is 1, -5, and whose y-intercept is -3. So when I'm given the vertex, I usually like to work from vertex form. So I know that I have some function f of x. What I'm not given is my a value. So I'm going to have to solve for my a value. And I have x minus 1 for my h. And then my k value is -5. And there I am in my vertex form. So I'm given another piece of information that 0, -3 is a solution to this. So I can plug in, so I know that f at 0 is -3, so -3 is equal to a times 0 minus 1 squared minus 5. Now I can solve for my a value. So -1 squared is just going to be 1. So I have -3 is equal to 1a. So I just have 1a minus 5. If I add 5 to both sides, I get a value is 2. It's positive, so it opens up, so it makes sense. So my final equation here is f of x is equal to 2 times x minus 1 squared minus 5. Okay, so we should be able to look at a graph and given a couple points, come up with the equation as well. Next example, dealing with the word problem. So John Deere Company has found that a revenue from sales of heavy-duty tractors is a function of the unit price P that it charges. If the revenue R is given by this equation, -1/2 P squared plus 1900 P, what unit price P in dollars should be charged to maximize revenue? So if this equation, I see that it's a negative a value, so it's going to have a maximum at some point. So I want to find that maximum. I want to find my vertex. Okay, to do that, to maximize my revenue, I can find my vertex. So again, in standard form, I can identify my A being -1/2, my B being 1900, and my C being 0. So to find the x value of my vertex, my maximum point, I'm going to do negative b over 2a. Well, negative b is -1900 over 2 times -1/2, which is just going to simplify to 1900. So that's my x values. So that's the unit price that should be charged to maximize my revenue. This is equal to the P, okay, for the unit price, so charge $1,900, and the maximum revenue. So what will the revenue be at that price? So I do R at 1900. It's going to be equal to -1/2 times 1900 squared plus 1900 times 1900. All right, so I'm going to use my calculator on this one. All right, so I'm just going to do -0.5 times 1900 squared plus 1900 times itself, so it's squared again, or you can just do times 1900. Is that. So I see that I make 1 million. So the actual revenue generated here is $1,805,000. Okay. So that concludes our notes for the night. Make sure you highlight any questions you have and bring them to class tomorrow.